Hi, my name is Chris from the ARMedONE project team, and today I would like to talk a bit about one of the use cases you can use our ARMedONE carrier board for. In this case, I'd like to talk a bit about distributed rendering with tools like Blender, which is one of the most common 3D modeling and 3D animation, 3D rendering tool out there, which I use personally as well. So when it comes to rendering or 3D modeling in general, the modeling part isn't the most complicated thing of the whole process. In my opinion, one of the most complex problems is to finally render the complex scene you've designed in Blender out into some kind of video, into some file. And in my project, often it was that I did quite an interesting, quite a brilliant scene with complex animations and stuff like that, and then I click render and my small little PC, or in this case my MacBook, starts to sound like a starting jet plane and goes into render mode for multiple days and couldn't be used for anything else. That's a problem, isn't it? When looking for a solution, I came across something that is called distributed rendering. The idea behind it is to take multiple smaller or even bigger PCs, if you have some in your hands, and distribute the whole rendering process to all of these machines. So you do not need one big machine which is able to render everything quite fast, but you can use smaller, oftentimes more cheaper computers, or in this case compute modules like NVIDIA Jetsons, to be specific NVIDIA Jetson Nanos, to take the big chunk of rendering and chuck it down into smaller chunks, which can be then handled by these smaller devices. How that is possible and how that is done in this special case with our ARMedONE carrier board, which is currently live at Kickstarter, if you want to get one at a huge discount, will be topic of this video. The tool we use to distribute the rendering work to all these machines is Blend Farm from the awesome Logic Rank, which is a standalone Blender network render, and it has some quite fancy and quite unique features on board. Not only is it open source, but it's cross-platform as well, so you can use your Windows gaming PC with standing around to render beside your old MacBook Pro or your Mac Mini or the bin-shaped Mac, however it's called, or even some ARM SoCs like the NVIDIA Jetson Nano or other compute modules. It's no problem. Blend Farm from Logic Rank handles it all quite well. And the best part, setup of the Blend Farm application is quite simple. It comes with a distributable bin or a DMG file or exe file if you run it on Windows, and is a client-server architecture. So on one of your devices, mostly your daily workhorse, you run the client, the GUI application, and on all other machines you want to use for rendering, you run the Blend Farm server. But how to do this, and most important, how to make these setup as easy as possible with our ARMedONE carrier board and some modules you have lying around, like in my case NVIDIA Jetson Nanos, will be explained in the next few minutes. Setup of the physical components is quite simple. You add power and Ethernet connection to the ARMedONE and add as much compute modules as you like to the carrier board, which can handle up to 28 of them without any hassle. For the software part of the installation, we build up a small solution using Ansible, which is a task runner for multiple devices and operation systems, which makes sure everything which is needed for blend farm, like enough space on the SD card of the module, the right software installed on each module, like Blender, different packages and stuff like that, is all packed into this solution. So when you install them on your own modules, you just have to know the IP addresses of your modules, and then it's not more of than a button click to start all the installations you need. For this small demo, I added 3 NVIDIA Jetson Nanos to my ARMedONE carrier board, and since 2 of them are already proper installed, we only add one IP address, in this case 192.168.0.7, to our config file, so the Ansible scripts will know how to reach the Jetson where everything needs to be installed. Next up, we switch to our task list and start with the first thing we need to ensure to be present on the Jetson, which is ensuring the SD card is at least 30 GB in size. Most of the images you will find on the internet for the NVIDIA Jetson Nanos are quite small, like 24 GB, which isn't that much if you want to render big blend files. So we just wrote a small script which checks what is the maximum size of the SD card and then enlarged the card itself and the partition, the root partition of the file system to use all the space. This process takes quite some time, so it's sped up here in this demo, and as you can see, everything ran quite fine. And don't worry if you accidentally start the script again. The first thing the script will do is to check if it already runs, so if the SD card is already set up properly. If that's the case, the script stops, so you will never ever kill an SD card or invalidate a system with one of these install scripts. The second and last thing we need to do is to ensure that the whole blend farm process is installed and set up on this application. For this, we use the ensure blend farm is installed task and click on run again. And as well, this task takes quite some time. It makes sure that some apt packages are installed which are needed, that Blender is up and running on the system, and it unpacks the blend farm binary and configs to opt/blend farm. So that's where you can find, and furthermore, it creates a system service. So whenever you restart the module, you do not have to think of, oh, I need to start the blend farm service as well. It gets started for you. After all modules and PCs are set up properly, we can start the blend farm application on our main machine. After it started, we are able to select the blend file we want to render, or even choose it from the most recent renderings we done or at least started. And we are able to choose what version of Blender will be used for this rendering. As you can see, a lot of versions are available, but please keep in mind, for ARM processors like they are used on the NVIDIA Jetson Nano, not all versions are currently available. There probably will come up some more or some new versions in the future, but currently we use for these distributed rendering the 2.83 version, which works quite fine. After the click on load projects, the main window of blend farm comes to the front. On the left side, which is quite blank at the moment, we will see the render progress once we started rendering. On the right bottom side, we have the settings area where we are able to set the width and height of the final rendered image. We are able to set the render target to animation and to set a file format and from what file we want it to start and end, and what the output format is, like PNG or anything, basically anything else you're able to select directly in Blender as well. On the last pane, which is named System, we're able to set some more of meter information which are needed for blend farm itself. So basically you're able to decide what is my render strategy, so how is my big file chunked down into smaller pieces. So most of the time split horizontal works quite well, but there are different settings here which you are able to all test by yourself. In the end I will show the chunked version, which is in my opinion quite handy for smaller devices like ARM-based Jetsons. After we made our settings, we have to choose which modules we would like to use in the specific render. For that we click on the small red dots right next to the name of the module and its IP address. The list of modules is auto-populated, so blend farm knows what other blend farm scripts are started on other machines, so you do not have to remember any kind of IP address and stuff like that. When you click them, they turn green and you have to finally click on Sync All. This will copy your blend file you've chosen before to all of these modules. The last thing to do is to click on Render. Now blend farm will chunk down the big blend file into smaller chunks and send them off to all modules you've chosen to participate in this render. Whenever one of these small tasks gets finished, you will see it appearing on the left side of the blank canvas, and the machine will get assigned the next task, the next chunk to render. Again, I sped up the process so we don't have to wait like 15 to 20 minutes for this whole render to finish. As I said before, there are different strategies for chunking down blend files. Just to show another one, in this case I choose the render strategy which is named chunked. So in this case it's not column based, but small little dots, like in this case I think 20 by 50 pixels or something like that, starting from the middle, which are distributed to all of these small modules. And the smaller the task itself, the faster the different modules are able to work on this task. And blend farm distributes this work quite smart. So it doesn't wait for all modules to finish their current job before issuing the next jobs, but whenever one module ends its job, it gets the next chunk from the stack, so it renders the fastest way possible. That's it for today. I hope I could give you a small overview about how distributed rendering with the ARMedONE carrier board works. If you have any further questions, just join our Discord on discord.rs-blockchain.gmbh, or even better, support us on Kickstarter. Spread the word of the ARMedONE carrier board, back the board during this campaign. You get a huge discount against the retail price. If you want to get more information about the Kickstarter, just follow the link you see now on your screen, or type into your browser kickstarter.armedone.rocks, and feel free to ask any questions down below in the comments or on our Discord. I'm glad to help and glad to answer any question you might have.